All right, welcome back. We're going to continue our work on section 4.1 by talking about initial value problems and differential equations. Although this sounds a little bit different, these are going to be related to the things that we talked about in the last video. We first need a definition. A differential equation is any equation that includes a derivative. A differential equation is any equation that includes a derivative. A differential equation is any equation that includes a derivative. So for example, if I give you 2x minus 3 dy dx equals 6y, that is an example of a differential equation. I'll pause so you can copy that down. The goal of a differential equation, solving a differential equation, means finding a particular function, y of x, that would make the equation true. Our goal is to find a function y of x that makes the equation true. So I want to find a function. So if I do 2x minus 3 times the derivative of my function, I get 6 times that function. In general, this is very difficult to do. In fact, there are entire college courses devoted to solving these differential equations. We are not going to look at things that are quite this difficult for right now. We're going to start with some easier things. For example, we're going to solve the differential equation dy dx equals x cubed minus 4x. I want to solve that differential equation. Dy dx equals x cubed minus 4x. This equation is asking us the question, what function, y of x, has a derivative of x cubed minus 4x? Let me write that down. What function, y of x, has a derivative of x cubed minus 4x. Any idea how we could figure this out? What function has a derivative of x cubed minus 4x? I'm hoping that you're thinking that this question sounds like what we did in the last video. I'm giving you the derivative. I want to know the original function that it came from. That sounds like all I need to do is find an antiderivative. My function, y of x, is just going to equal whatever the antiderivative of x cubed minus 4x dx is. Well, that's nothing new. That's what we did in the last video. You take a moment, find the antiderivative. The only difference here is rather than our answer being an expression, our answer is going to be a function. You're just going to say y equals whatever you get for your antiderivative. So go finish this off. What's the antiderivative? Y equals, okay, add 1 to the power, x to the 4th over 4, divide by the new power, minus 4x squared over 2. Don't forget that plus c at the end. I'll clean it up just a little bit, and I'll say y, or y of x, doesn't matter, equals 1/4 x to the 4th minus 2x squared plus a constant. Next, when we're dealing with solving these differential equations, there are two different types of solutions we're going to have to deal with. Two types of solutions. First, we have what we call a general solution. And these are solutions that include a constant, that include a plus c. A general solution to a differential equation includes a constant, includes a plus c. And this is everything we've already dealt with so far in terms of antiderivatives. We always get a plus c at the end. That's our constant of integration. We're now going to start focusing on what we call particular solutions. In a particular solution, if I give you a little bit of additional information, we can find a specific value for c. So we'll say, given additional information, we can find a specific value for c. So when we're done, we might not have a plus c anymore. We might have a plus 5 or a plus square root of 2 or some actual number in there. Please copy those down, then I'll show you some examples. Okay, so for example, we are going to solve the differential equation y prime of x equals x squared minus 5x plus 4. I'm going to tell you that y of 0 equals 2. We're not going to care so much about this for right now. We'll deal with that part later. But this piece of information is called our initial condition, which is also why these are sometimes called initial value problems. I'm telling you a little bit of additional information, some initial value. We'll use that to find our value of c. We're not going to worry about that for right now. I'm giving you the derivative, want you to find y of x. So y of x is going to equal the antiderivative of x squared minus 5x plus 4 dx. Please take a moment and integrate that. I'll make the video pause. Y of x equals 1/3 x to the third minus 5x squared over 2, not sure why I'm mixing the notation, but whatever, plus 4x plus a constant. And this is my general solution. But now, I don't know if that's helping. Give me one moment just to open the window. Okay, so now I want to find a specific value for that constant. Any idea what we can do to figure out a specific value for c? I'm going to take this initial condition and I'm going to plug this in. I'm going to plug in 0 for x and 2 for y. And I'm going to get an equation that I can solve to figure out my constant. 2 equals, well, 0 minus 0 plus 0 plus c. I'm thinking 2 equals c, which means I'm going to get y of x equals 1/3 x cubed minus 5/2 x squared plus 4x plus 2, and I'm going to call this my particular solution to a differential equation. I gave you a little bit of extra information. We could find a specific value for c.
I found these results.
Oh, good, and my phone is talking to me. Please copy that down. Let's take a look at a couple other differential equations. Let's look at the differential equation. Y prime of x equals cosecant x cotangent x. And I'm going to give you the extra piece of information, the initial condition, y of pi over 2 equals 3. How do I solve this? Well, y of x is just going to equal the integral of the cosecant of x times the cotangent of x dx. I think you can integrate that. Please integrate that and get your general solution. Y of x is going to equal, well, I know from my basic antiderivative rules, this is negative the cosecant of x plus a constant. And now, I just need you to plug in pi over 2 for x, 3 for y, and solve to get your c. What's your c value? So 3 equals negative cosecant of pi over 2 plus c. Cosecant, I don't really like cosecants, I'd rather do sines. The sine of pi over 2 is 1. Cosecant of that is 1 over 1, so 1. Negative 1 plus a constant. Our constant's going to be 4. Our particular solution is y of x equals negative cosecant x plus 4. That's it. Now, this differential equation that I gave you is an example of what we call a first-order differential equation. I can call this a first-order differential equation. And all that that means is it's a differential equation that only involves first derivatives. I only have y prime. As I believe you can probably imagine, if I have first-order differential equations, I must have second-order or third-order or fourth-order or whatever. We're now going to look at a second-order differential equation. We're going to solve the differential equation y double prime of x equals 3x squared minus 4x minus 2. And I'm going to call this a second-order differential equation. I'm also going to give you a little bit of additional information here. I'm going to tell you that y prime of 1 equals 5, and I'm going to tell you that y of 2 equals negative 3. Y double prime of x equals 3x squared minus 4x minus 2. Y prime of 1 equals 5, and y of 2 equals negative 3. Well, I want to find the original function, and I can't do that directly. What I need to do is I first need to figure out what y prime of x is, get a formula for that, and once I'm done with that, I can then find what y of x is. Y prime of x is going to equal the integral of 3x squared minus 4x minus 2 dx. See if you can figure out the particular solution for y prime of x. Find the antiderivative, get your plus c, and then use this information to find your c value. See what you can get for y prime of x. Okay, so y prime of x should equal 3x cubed over 3 minus 4x squared over 2 minus 2x plus a constant. So y prime of x is going to equal x cubed minus 2x squared minus 2x plus c. I told you that y prime of 1 was 5, so we're going to plug that in. 5 equals 1 cubed minus 2 times 1 squared minus 2 times 1 plus a constant. 5 equals 1 minus 2 plus c. Negative 1 minus 2 is negative 3. 5 equals negative 3 plus a constant. Your constant is 8, which means your particular solution for y prime of x is y prime of x equals x cubed minus 2x squared minus 2x plus 8. Actually, I probably shouldn't have sighed there because we're not done. We're only halfway done. That was y prime. I now want to find y of x, which means you need to go and integrate this again. It's going to get a little bit messier, but that's okay. See what you can do. see what you can do without a calculator on this, because when we do have a test on this, something like this would be non-calculator. And how about an Edpuzzle? Just submit the value you get for C in your y of x. Okay, so y of x equals 1/4 x to the 4th minus 2/3 x to the 3rd minus 2/2 x squared plus 8x plus a constant. That's really just 1, I don't need that. I'm now going to plug in my initial condition of y of 2 equals -3. -3 equals 1/4 times 2 to the 4th minus 2/3 times 2 cubed minus 2 squared plus 8 times 2 plus a constant. 2 to the 4th is 16. A fourth of that is 4, so -3 equals 4 minus 2 cubed is 8 times 2 is 16 minus 16/3, and deal with that later, minus 4 plus 16 plus c. You know what, maybe I'll just deal with the fraction at the very end. I think I can deal with everything else. 4 minus 4 is 0, plus 16 is 16. -3 equals 16 minus 16/3 plus a constant. I'll subtract not 16/3, just 16 from both sides to get -19 equals -16/3 plus a constant. I'll add 16/3 to both sides. Guess I need a common denominator to do this, so -57/3 plus 16/3, I believe, is -41/3, which is maybe what you submitted. So y of x is going to equal 1/4 x to the 4th minus 2/3 x cubed minus x squared plus 8x minus 41/3. And that's our particular solution. Next thing we're going to look at. We need to do a little bit more work with particle motion. And as I've told you every time we've done this, this is one of those topics that will kind of follow us through the whole course. Particle motion. Let me give you an example, and then we'll try to figure out what to do with this. A particle's acceleration is given by a of t equals t plus the sine of t. Its initial velocity is 0, and its initial position is 1. You are going to find its position at time t equals pi. Please copy that down. Okay, so these are not like the particle motion problems we're used to. You're used to me giving you the position, and then we can find the velocity, the acceleration, all that. But here I'm giving you the acceleration. You know that if I give you the position, its derivative is the velocity, its derivative is the acceleration. As I go down this list, I'm finding my derivative. How can we take acceleration and get the position out of that? Well, the way I can go up this list is I can integrate. And actually, what I gave you, thank you, Ms. Thompson, for shutting the door. They're about to change classes. Actually, what I gave you is a second-order differential equation. I'm giving you a second derivative here. Let me write this out. I've got a of t equals t plus the sine of t. The initial velocity is 0. That means the velocity at time 0 is 0. My initial position is 1, so s of 0 equals 1. And let's just ignore that question for right now. I'll find the position at time pi. I'll deal with that at the very end. Well, I've got the acceleration. We're going to find the velocity. The velocity is just going to be the integral of t plus the sine of t dt. You're going to do that, and when you're done, plug in your v of 0 equals 0. Figure out your particular solution for your velocity and submit that to Edpuzzle. V of t is going to equal 1/2 t squared. The integral of the sine of t is a negative cosine t. And don't forget the constant at the end. This is actually why the constants are so important, because the constants are how we deal with these initial conditions. 0 equals 1/2 times 0 squared minus the cosine of 0 plus c. Let's see. 0 equals 0. Cosine of 0 is 1, so minus 1 plus c. I think my c value is 1. So your velocity function is going to be v of t equals 1/2 t squared minus the cosine of t plus 1. Now, please go integrate that, get your position, and we'll use this s of 0 equals 1 to find the c. Please go find your particular solution for the position. Okay, so I'm going to go and I'm going to integrate 1/2 t squared minus cosine t plus 1 dt. S of t equals, I've got a 1/2 up front. Integral of t squared is t cubed over 3. Integral of cosine t is sine t, so minus sine t plus a constant. Might as well clean it up. S of t equals 1/6 t cubed minus sine t plus c. I'll plug in my 0 and my 1. 1 equals 0 minus the sine of 0 plus 0 plus c. Okay, so, oh, you know what? This is really nice. Sine of 0 is 0. 1 equals 0 minus 0 plus 0. I think my c value is 1. So I think my position function is s of t equals 1/6 t cubed minus the sine of t plus 1. And that's it. Oh, actually, no, that's not it. Now, I need to go back to what I was asked. I was asked to find the position at time t equals pi. All we're going to do is we're going to plug in pi. It's not pretty, but go find s of pi. One-sixth times pi cubed minus the sine of pi plus pi plus 1. Okay, pi cubed over 6 minus sine of pi is 0 plus pi plus 1. Where is the particle at time pi? It's at pi cubed over 6 plus pi plus 1 along the x-axis. One last thing I want to show you. For those of you taking physics, you have all those different formulas in physics and stuff. I just want to show you where one of those formulas comes from, because calculus was actually invented to solve certain problems in physics. So I hope I get the notation right here. If you've taken physics, or if you're taking physics, I'm sure you've talked or are talking about free fall motion. I hope it might be a little bit early if you're a quarter 2 student. If you've taken physics or will take physics, you're going to talk about throwing an object in the air, figuring out how high it goes, when it reaches the ground, all that sort of stuff. Free fall motion, where really the motion is just guided by gravity. That's the only thing working on the object. I can never remember exactly what notation Mr. Coakley or Mrs. Istvan use. I want to say you've been given a formula like this: x equals 1/2 gt squared plus v naught t plus x naught. Maybe, hopefully this looks familiar. Actually, I think I remember being told that you don't usually have an x naught, you just assume you're starting at a height of 0. But we can add in an initial height as well. That's what we have over there. This formula comes from the fact that when an object is thrown in the air, the acceleration on the object is constant and just due to gravity. So, I can say that my acceleration formula is just a constant g. I can say that my initial velocity is 0. Actually, no, it's not. My initial velocity, my velocity at time 0 is v naught. And I can also say that my initial position, I'm going to use x rather than s, same meaning, is going to be x naught. I can create this formula by doing some integration. My velocity is just going to be the integral of my acceleration. Okay, well, let's integrate the acceleration. Let's integrate that g dt. If we integrate a constant, we just get that constant times my variable, so g times t, plus another constant. I told you that the velocity at time 0 is v naught, which means if I plug in 0, I get v naught equals g times 0 plus a constant. My constant is v naught, which means my velocity formula is gt plus v naught. And hopefully this is also a formula you've seen if you're taking physics or have taken physics. To get my position, I'm going to integrate again. X of t equals the integral of v of t dt. X of t equals the integral of gt plus v naught dt. X of t equals, well, g is a constant that I'll leave out front. Integrate t, you get t squared over 2. Integrate v naught's a constant. You get that constant times my variable times t. At the end, we get another constant. Plug in your 0 and set it equal to x naught. X naught equals, well, this whole thing is going to become a 0, plus a 0, plus c. My constant is x naught, giving me a formula of x equals g times t squared over 2. I can just write that as 1/2 g t squared plus v naught t plus x naught. That formula just comes from integration. That formula comes from the fact that your acceleration due to gravity is a constant, and we can integrate that twice. Don't worry so much about this. I just figured, since many of you are taking physics, it would probably be good to see where that formula actually comes from, and it just comes from calculus. The reason we can't use those formulas, though, by the way, in here, is because this formula was good if your acceleration was a constant. In the previous problem, no, our acceleration wasn't a constant. Our acceleration was a function itself, so the only way to deal with that is by using our tools from calculus.